So yesterday we discussed the formation of the ionic bond. Basically, the formation of ionic bond, what happened, the bond which is formed between the metal and the non-metal, and how we can identify the metal and non-metal. So when we draw this staircase, on the right hand side of this staircase, what we will find, we'll find non-metals. On the left hand side, we'll find metals. So if one of the element belongs to one side, like on the left hand side, and another element belongs to the right hand side, when they combine with each other, they will form an ionic bond. So the metal will lose electron and the non-metal will gain electron. So example, like formation of sodium chloride. So chlorine belongs to group 7, so it is having 7 electron in the outermost shell. Chlorine belongs to group 1, so it is having 1 electron in the outermost shell. Metal tend to lose all of their valence electrons, so the sodium will lose its electron. So what will be the charge? As it loses one electron, it will be positive, and the outer shell will be empty as it lost electron. And what about the charge on chlorine? Because chlorine took one electron from sodium, so the charge on the chlorine will be -1. And the attraction between the positive and the negative ion is known as the ionic bond. Another same example, like sodium chloride. Sodium is having, in the last shell, it is having one electron. Chlorine is having 7 electrons. So sodium lost that electron and chlorine gained. So sodium will get a positive charge and chlorine will get a negative. And electrostatic attraction between them is known as the ionic bond. So sometime they ask to draw the complete structure, like showing all the shells. So if they ask to show all the shells, then this is how you should draw the structure. But sometimes they only ask draw the valence shell. Valence shell means last shell. So if they're saying draw the valence shell or last shell, so as sodium belongs to group 1, it is having 1 electron, and chlorine belongs to group 7, so it is having 7 electron. So you just have to show the valence or the last shell. So both ways are correct depending on how they ask the question. And when these ions join together, they arrange themselves in a regular pattern. What we call that? We call that as a lattice. So lattice is actually a regular arrangement of positive and negative ions here in ionic compound. Then these are the properties for ionic bonding. This result in an attraction between the positive and negative ions and occur when the metal react with a non-metal. And what are the properties of these ionic compounds? These ionic compounds does form an ion, because ionic compounds are formed by metal and non-metal, or it is having ions. So there is a positive ion, then negative, then there will be a positive, negative, and so on. So this regular arrangement, what we call this regular arrangement, we call that as a lattice. So these ionic compounds can conduct electricity in a liquid or aqueous state, but they cannot conduct in solid state. Why the ionic compound does not conduct electricity in a solid state, but they can conduct in a molten or aqueous state? The conduction of electricity means movement of the ion. So why ionic compound does not conduct electricity in solid state? So if the question is why do ionic compound does not conduct electricity in a solid state, so your answer should be because in solid state ions can vibrate, but they cannot move from one place to another. So example, if you have a lattice of sodium chloride, so there is a positive ion and a negative ion. So this a regular arrangement of the positive and negative ion, what we call that as a lattice. So why in a solid state they are not able to conduct electricity? If this is an ionic compound, one is a positive ion, then negative, positive, negative, positive, negative, and so on. So the lattice is having a regular arrangement of the ion. So lattice is a regular arrangement of the ion. What happened? Why in a solid state ionic compounds are not able to conduct electricity? Because these ions can only vibrate. Like this is a positive ion, so this positive ion can only vibrate, but it cannot move from one place to another. For conduction of electricity, these ions must travel from one place to another, but this does not happen in a solid state. Ions can only vibrate, but they are not able to move from one place to another. That is why ionic compounds does not conduct electricity in solid state. But what happened in a why the ionic compound can conduct electricity in a molten? In molten or aqueous state? So why ionic compound conduct electricity in a molten or an aqueous state? Because in molten and aqueous state, like when you add salt to water or when you melt the salt, what happens? The ions are free to move in the molten and aqueous state. So example, if you have a container, say this is a glass, and you fill this glass with water. So this glass is filled with water, and what you did, you're adding a salt. What is basically this salt? Salt is an ionic compound, and normally the salt which we are using, it's either a sodium chloride or iodide. So when we add a salt, initially this is a lattice which is having a positive and negative ions. But when you add this salt to water, the ions are separated. The positive and negative ions are separated from each other. So as these ions are separated from each other, these ions can move from one place to another. So that is the reason ionic compound can conduct electricity in a solution or in a melted form, but they cannot conduct electricity in a solid state. Is it clear that why ionic compounds cannot conduct electricity in a solid state, but they can conduct electricity in a molten or aqueous state? Is it clear to everyone? So in a solid state, they have ions have a regular arrangement and ions are fixed. They are not able to move. They can vibrate, but they are not able to move from one place to another. Salt is an example of ionic compound, like the normal salt which you have. Example, this is a crystal of salt. The salt which we are using is an ionic compound. So it is having positive and negative ions. So this is a lattice of the salt, or you can also say ionic compound. Salt like sodium chloride, which is in a solid state. So when you have a salt such as sodium chloride in a solid state, when you try to pass the current, it will not conduct electricity. It does not conduct electricity. So what is the reason why it does not conduct electricity? Because these ions are not free to move. Like this positive ion here cannot go from one place to another. So it is not free to move. That is why it cannot conduct electricity in a solid state. But if you add this salt to a container or to a which is filled with water, so the moment you add this salt to water, the salt will dissolve. So when the salt dissolves, these ions are now separated from each other, the positive and negative ions initially which were in contact with each other, but now they are separated and they are free to move. That is why in a solid state, in a aqueous state or a dissolved form, this solution can conduct electricity. So when we add water to ionic compound, the ions are free to move, so it can conduct electricity. Is it clear? Why in a solution it can conduct electricity, but in a solid state it does not conduct electricity? Is it clear to everyone? So these are the properties of ionic compound. Ionic compound, when they are in solid, they are not able to conduct electricity. But when we add water, the ions become free to move, and that's why it can conduct electricity. So the properties of the ionic compound which we are discussing, they does form ions, so it will conduct electricity in a liquid or aqueous state. When we melt them, they can conduct, or when we dissolve them, aqueous means you dissolve them or make a solution, it can also conduct electricity. And they form a crystal lattice. Crystal lattice means they have a regular arrangement of the ion, and ionic compounds have high melting point. Means you need more, because strong force is there between the ions, so you need greater amount of energy to separate the ions from each other. Now some questions related to ionic compound. Which statement about ionic compound is not correct? A, B, C or D? You can use the screen annotation. The question is, which statement is not correct? Not true or not correct for ionic compounds. You can use the screen annotation to state the answer. Yeah, that's right. C is a right answer. Why A is not? Because the question is which is not correct, or which is not the true statement. Ionic compound can conduct electricity when dissolved in water. That's true. It has high melting point due to strong attraction between the ions. That's true. It has a regular lattice of oppositely charged ion in a sea of electron. There is no sea of electron. Sea of electron means like many electrons are there in the structure. So that is not the true statement. They have a regular arrangement of oppositely charged ion. So this statement is true till the ions. But in a sea of electron, that's an extra thing which is written, so that makes statement wrong. And ionic bonds are formed between metallic and non-metallic elements, so that is also true. So C is the right answer. Is it clear to everyone? Discussion. Another question. What is the meaning of sea of electron? Like example, when we draw the ionic compound, how we represent? There is a lattice of the positive and negative ion. So we have positive and negative ions. This is what happen in ionic compound, the lattice of positive and negative ion. But what they mean by sea of electron, they mean that nearby them electrons are there. Like these positive and negative ions are there in a sea of electron. Like lot of electrons are there around them. But that is not true, because this is not in a sea of electron. How ionic compound exists, they exist as a lattice of positive and negative ion, but not the sea of electron. So only what we find a positive and negative charges in the structure. We don't find a sea of electron. If this statement has to be true, then what should be the, it should end at this point only, that it has a regular arrangement of oppositely charged ion. That's it. If this was written, then this will be the right statement. But the sea of electron is an extra they added, so which make this statement wrong. Is it clear to everyone? Another question. Rubidium is in group 1 of a periodic table and bromine is in group 7. Rubidium react with bromine to form an ionic compound. Which row shows electron change take place for rubidium and the correct formula for rubidium ion? Rubidium belongs to group 1. So if it belongs to group 1, means it will have one electron in the outermost shell. And group 1 means it is a metal. So it tend to lose electron. So what should be the charge and whether it should lose or gain electron? So that's true because it's a metal. Group 1 means one electron in the outermost shell, so it should lose one electron. And when it will lose one electron, it will have a +1 charge, so C will be the right answer. The electronic structure of two atoms P and Q are shown. So they show atom P and P and Q combine to form a compound. Can you identify which group P belongs to? Which group element P belongs to? It is having 7 electron in the outermost shell. 2, 4, 6 and 1, 7. Yeah, that's right. It's group 7. and so it means P belongs to group 7 and Q belongs to group 1 because there is one electron in the outermost shell. So what will be the valency of P? Because P belongs to, yeah, that's right, because 9 electrons are there, so fluorine, element fluorine is there. So P belongs to group 7, and when it belongs to group 7 means it will be a non-metal. And Q belongs to group 1, so means it will be a metal. And when metal and non-metal will react, so it should be ionic. So either A will be answer or B will be answer. Then what will be the formula of a compound when P reacted with Q? So Q valency group 1, so it will be +1 and P group 7 -1. So the formula should be QP. QP or PQ because that will not make difference here. That's why A is the right answer. Is it clear? This is a structure question. They mentioned sodium chloride is a typical ionic compound. The diagram shows a part of a lattice of a sodium chloride. Complete the diagram to show the ions present. Use positive for sodium and negative for chlorine. One ion has been completed for you. So this is plus. So next to how to complete an lattice. So if this is plus, next to plus should be minus. And if this is minus, next to minus should be plus. If this is plus, next to plus should be minus. If this is minus, next to this should be plus. If this is plus, next to this should be minus. And if this is plus, next to this should be minus. And here it's minus, so next to this should be plus. So we completed the structure of sodium chloride lattice. Because there is a alternate positive and negative charges held together by a strong electrostatic force. Then how many electrons are there in a chloride ion? So how we'll know how many electrons are there in a chloride ion? So how to know chloride number of electrons in chloride ion? So you have to check chlorine atom first. When you check chlorine atom is having 17 electrons. So when sodium react with chlorine, so basically what happens, sodium belongs to group 1, so it is having 1 electron in the outermost shell, and chlorine belongs to group 7, so it is having 7 electrons in the outermost shell. One of the electron jumps from sodium to chlorine, so sodium loses 1 electron and chlorine gain 1 electron. This is not the full structure, this is only the outer shell. So normally chlorine atom is having 17 electrons. So how many electrons should be there in chlorine ion? So how many electrons should be there in chloride ion? As it gain electron, 1 electron. So that's right, it should be 18 because 17 are there already there in chlorine atom and 1 it took from sodium. So total number of electron will be 18. Then identify which atom has the same number of electron as sodium ion. So how many electron will be there in sodium ion? When we check sodium atom, sodium belongs to group 1, it is having atomic number 11, so it will have 11 electrons, sorry. Now for sodium ion, because it loses 1 electron, yeah, we can also use Z minus the charge, that's true. So sodium atom is having 11 electrons. When it loses electron, how many electrons will be left? It will left with 10 electron. So in the question they're asking, identify the element which has the same atom has, identify the element which has atoms with the same number of electrons as sodium ion. So sodium ion is having 10 electrons. So we have to use a periodic table and identify which element is having 10 electrons. So using a periodic table, which element can you identify which element is having 10 electrons? Because using a periodic table, we have to find the element which is having 10 electrons. So that's neon, you can see, because in neon there are 10 protons, so you should have 10 electrons as well. So the answer here, it was 18, and in this one it is neon. Is it clear, this question? So this was about the ionic bonding, ionic structures. So you should be able to draw the ionic structure, you should be able to draw the lattice and work out the formula and number of electrons in an ionic compound. The term lattice refers to regular arrangement. When you have something which is having a regular arrangement, we use the term lattice. So lattice is basically something which is having a regular arrangement, we call lattice. So the lattice of ionic compound is having, why we call a lattice? Because it is having a regular arrangement, a definite arrangement is there for the ions. So whenever something is having a regular arrangement, we use the term lattice. Then the second topic is about the covalent bond. So you should be able to draw the covalent structure as well as work out their properties. Again, we have to use a periodic table. So covalent bonding, the bond which is formed between the two non-metals. So when we draw the staircase here, so if we have elements on this side and including hydrogen as well, because that's also a non-metal. So whenever we have elements on this side, when they react with each other, what kind of bonding they will have? They will have covalent bonding. And what happen in a covalent bonding? In covalent bonding, is formed by sharing of electrons between the non-metals. So when non-metals are there, they tend to share electron, and when they share electron, yes, the ionic is done. Now we are starting a covalent. So covalent bond is formed by sharing of electron between the non-metals. And what happened in covalent bonding? You have to remember this table. If it is group 4 non-metal, it will share 4 electrons. If it is group 5 non-metal, it will share 3 electrons. If it is group 6 non-metal, it will share 2 electrons. And if it is group 7 non-metal, it will share 1 electron. And group 8 does not share any electron. Another question about how atoms were seen if they are so small, how did they found out about atomic structure and weighing the proton, neutron, and electron, and how they discover all this? This cannot be seen by us. Yeah, that's a good question, Yusra. Look, basically what happened, we are not able to see individual particle, but what we are able to see, we are able to use a microscope which is known as electron microscope. So using the electron microscope, we are able to identify or mention the structure of the atom. So basically what happened with the naked eye, we are not able to see, but what happened during there are different process like thermionic emission, we are able to move the electron from one place to another. A beam of electron is there, and these electrons are focused on the structure which consists of atom. So when these electron passes through the structure, we are able to sketch an image of the atom. So directly we are not able to see, but we are able to sketch image of this atom. Then the second part of your question, then how we are able to work out the mass of neutron, proton, electron. So there is a device which is called a mass spectrometer. This mass spectrometer is used to find, it's a device which is used to find the mass of the particle, and it is a sophisticated device which based on different principles, like it use electric field, magnetic field, ionization, vaporization, and detection. Using that mass spectrometer, we are able to find the mass of different particles. Is it clear? And the discovery, when you check the discovery of the atom, it's not like they focus on, like they are able to discover this atom directly. Actually the discovery of the atom or the particle like subatomic particles such as electron, this is an accident. It was not like they're focusing on discovering this particle, but accidentally they discovered that some particles are coming out from the atom, and they named these specific particles such as electron, proton, and neutron.